Give you about 20, 30 seconds. See what you can do. See if you can get simplified all the way on example 2. Okay, let's check it together. All right, so again, we're going to pretend multiplication is just like simplifying. So we're going to add, you don't have to do this and add those parentheses, but it's all it is simplifying. Okay, is there anything that crosses out 1 for 1 right away? There's an X. Good, so that's gone. We don't need to think about it anymore, right? All right, do we have any numbers that can cancel a little bit? 5 into 10, how many times? Twice. Good. Are there any other numbers? 2 into 6, how many times? 3. It's getting kind of messy, so I'm going to go ahead and write out what I have left now. I'm going to put the 3 up front just because I like numbers up front. And then we've got an x squared and a y cubed in the numerator. And I've got a y squared and a y in the denominator. I'm multiplying these. Technically, when I am multiplying, what can I do with those exponents? Add them. And I could have done this in the last step as I was writing it down. So y cubed. So when I am adding those exponents, what do I get? What's 2 plus 1? 3. You can't see what I'm doing. Okay, 2 plus 1 is 3. And then what happens from there? What do we cancel? The y's cancel out, so I just end up with 3x squared. Okay? Yeah.
What do you do with the other 2?
With
you didn't bring them down.
Which 2?
On purpose. When you canceled the 5 and the 10.
Oh, I totally missed it. Thank you. So Avery's talking about this 2 here. I missed bringing that down, so I should still have a 2 in the denominator. Thank you for catching that. All right, everybody good with that now? Okay, so that's monomials. That's kind of its own thing, okay? So, and we've been working, like I said, we've been working on that for a while. Let's now talk about example 3, 4, and so on. Let's review really quickly kind of our factoring rules, okay? And we're going to review factoring rules out in the left-hand column here, okay? So first thing we look for when we factor is always a what? Yep, greatest common factor every single time, okay? Then we count the terms. If we have 2 terms, we look for difference. I need you to know the names of squares because you're going to tell me, oh, that's a difference of squares factoring. That's a greatest common factor factoring. That's a magic X factoring, okay? Then if we have 3 terms, we look for a magic X or a magic X with a box, right? Or an X box. Okay, so that's the order of things that we do. Okay. This is no different than what we were doing yesterday in class, except that there's more factoring to it. Okay. So I could put parentheses around these, connect this. Now it's a simplifying problem. Okay. I just have a lot of factoring to do. So I'm going to draw one nice big giant fraction bar. Okay. And I'm going to start looking at factoring. So I'm going to start with this one right here. What's the very first thing I need to look for when I factor? What do we just write out in the left-hand column? Greatest common factor. Do I have a greatest common factor in there? 3x. Perfect. I'm going to pull that out. Okay. All right. When I divide a 3x out of 3x, what's left behind? 1. Okay, good. And when I divide a 3x out of negative 3x squared, what's left behind? Negative x, just negative x, right? If it helps you, okay, because I know a few of us were still struggling with this when we were working on the boards the last time. All we're doing, remember, is dividing this out. You could take this term here, divide by 3x, right? And you can really easily see that it's 1. I could take this term here, divide by 3x. I know those cancel. I subtract my exponents, and then I get what's here. Okay, so if that helps you, great. If I just made you worse, then don't worry about it, okay? You already know what you're doing. All right, I'm going to keep going across my numerator. So I'm going to factor that right there. What kind of factoring is that? Magic X, because we've got a trinomial, right? So 2 numbers that multiply to negative 20 and add to 1. What are they? Everybody good? Everybody agree? So x minus 5 times x plus 5 times x minus 4. And I want the binomials. Okay? All right.
I didn't get that. Could you try?
All right. I want, what kind of factoring is this one here? Magic x again, because we got three terms. So I need two numbers that multiply to negative 5 and add to 4. What do we think? What is the only thing that multiplies to 5? Which one has to be negative? 1. So x plus 5 times x minus 1. All right, and then that 3x is just going to stay 3x, right? There's nothing I can do with it other than it being 3x. All right, here comes the best part, right? We love it when we can cross stuff out in math. I don't know why it makes us feel so good, but it does, okay? So what can I just one for one cross out? Remember, we can only cross out over multiplication, so it has to be in parentheses there. So what can I cross out? X plus 5 is gone. What else? There's one other thing. I can't quite do the x minus 1s, right? Because look, that's a negative x, and that's a positive x. Does that make sense? I'm going to show you how to take care of that in just a second. There's one other thing. Yeah, the 3x is gone. Okay. I'm going to do two things at once. Okay, so I'm going to rewrite this. I know I have this x minus 4, and in the denominator I have an x minus 1. But we were very careful to observe that this is almost this thing down here, right? So this is one of those little, definitely makes it algebra 2, okay? Could I factor a negative 1 out? That could be a GCF, right? So I'm going to factor a negative 1 out of that. At the same time, I'm going to reverse the order of it. So when I factor a negative 1 out of 1, I get negative 1. When I factor a negative 1 out of x, I get an x. Now look at what I have left. Can I cross something else out? Now those match exactly. So I now can cross them both out. Okay, so I get negative x minus 4 with the parentheses around it as my final answer. That one is very satisfying. We got rid of almost everything, right? Sometimes we get rid of almost nothing. Sometimes we get rid of almost everything. Okay, let's try another one together. Okay, maybe with some different kinds of factoring. All right, let's see. Again, I'm seeing multiplication. I know I could throw parentheses around everything and connect it. Now it's a simplifying problem. Okay. All right, I start by drawing a nice big giant division sign, right? Because that's all that bar is division. Okay, that fraction bar is just division. All right, what's the very first thing I look for when I factor? Greatest common factor. Is there a greatest common factor there? 2x, perfect. All right, what do I get when I divide out 2x from 2x squared? Just an x, right? Think about it this way, 2x squared over 2x. What happens? Okay, what's left? All right, when I divide negative 10x by 2x, what do I get? Good. I can't do anything with the x plus 3. I'm just going to write it down the way it looks. It's already factored out or whatever, okay? Okay, let's look at this piece right here. Is there a greatest common factor? No. Okay, how many terms does it have? 2. So what kind of factoring is it? We wrote it down in the left-hand column. Difference of squares, right? So we're going to take our shortcut on that rather than having to do a magic x on it. So remember, difference of squares. What's the square root of x squared? X. What's the square root of 25? 5. We make 1a positive and 1a perfect. All right, I'm just going to write 2x squared down, right? Because there's nothing else I can do with that. And I really could, if I want to emphasize the parentheses, I could put parentheses in front of that 2x. All right, 1 for 1. What cancels right now? X minus 5. Anything else? The 2's go, right? Technically, that's multiplication in there. I'm allowed to cancel that. Could I do technically a little canceling on these? Think about what that says right there. It says I've got x over x squared. we could do our subtract exponents thing, right? Or could I think about it like this? So what would, how many x's would I get to cross out? 1, so I'd be left with 1x in the bottom. Does that make sense? So I'm kind of doing my subtract exponents thing and just putting making the number where it needs to be already, okay? Instead of moving it upstairs and moving it back downstairs, okay? All right, let's write out what we have left. So let's see, I've got, it looks like only thing in the numerator is x plus 3. And then my denominator looks like I have an x times an x plus 5. Typically, the monomial, the single term goes up front and the binomial goes in the back. It's not wrong to write it the other way. Just make sure you've got parentheses around the binomial. Okay? All right, we're going to try another one. See, I don't remember how many I have left in here. Let's see what we got. Let's see, I got 2 multiplying left. Okay, so let's see if we can get through the 2 multiplying. All right, we'll do one more together, and then I'm going to have you try one on your own. Okay, so we're going to do this one hopefully a little bit faster. All right, this is like what we were doing these problems earlier in the fall, right? We did these as one problem a piece. Now there's 4 problems in one. Okay. All right, but we should be getting pretty good at factoring by this point. This is one of those things that you got to walk in the door next year and just be able to do. Okay, so it's good that we keep repeating it. All right. I see multiplication. I know I could just add these parentheses around everything and connect it, and I have a simplifying problem. Okay? All right, what's the first thing I always look for when I factor? Greatest common factor. What's my greatest? Is there a greatest common factor in that first term? 6 what? Perfect. All right, what's left behind? So when I divide 6x squared by 6x, what do I get? Good. And when I divide 18x by 6x, what do I get? 3. Good. Okay, I'm looking at that one right there. I typically go across my numerator and then across my denominator. Some people do this fraction and that fraction, and it doesn't matter how you do it, okay? As long as you do all the parts. All right, do I have a greatest common factor in this one here? No. Okay, so what's next? Good, magic x. So 2 numbers that multiply to -2 and add to -1. -2 and 1. So we've got x minus 2 times x minus 1. Okay, what kind of factoring is that first one in the denominator there? Magic x again, no greatest common factor, right? And notice, the magic x is now not my main problem work, right? It's scratch work to the side. Okay, yeah. I put x, oh, thank you. That would have been bad later. Thank you for catching that. Okay. All right, so 2 numbers that multiply to -6 and add to 1. 3, -2. So I've got x plus 3, x minus 2. Anyways, this is scratch work off to the side. There's no need to like write the answer under there and then transfer it over here. We're leaving ourselves open for a lot of error when we do those transfers, okay? We saw a lot of that with our systems of equations. We'd write down one sign wrong and it would mess up the whole problem, okay? All right, this last one here. Is there a greatest common factor? No. What kind of factoring do I need to do? Magic x again, good. So 2 numbers that multiply to -8 and add to -7. Okay, so we've got x minus 8 times x plus 1. All right, we're under all kinds of multiplication there, right? So we're going to go ahead and start crossing stuff out. What do I get to cross out? Perfect. Anything else? I heard x minus 2 and x plus 1. Do you see how I did my slashies different directions? Even if I'm working in black and white, okay, if I do my slashies different directions, I can kind of track what went with what. That's why I do that, okay? Looks like that's it, right? That one was pretty satisfying. We got almost everything crossed out, right? So we've got 6x in the numerator and x minus 8 in the denominator. And the goal isn't necessarily to cross everything out. It just happened to happen that time, okay? You might have more left behind, and that's okay, all right? If things are not crossing out, you're probably doing something wrong, okay? So if you're not getting things to cross out. Okay, I want you, there's a typo on that one. There's a number missing at the end there, isn't there? Oh boy, and I don't have my thing open. Give me like a second to figure out what number is supposed to be missing there. Start factoring the numerator. You can start factoring that part. But I definitely have a typo on the denominator there somewhere. There's a number missing in the bottom there, so I'm fixing it right now. I'm trying to figure it out. It should be a 9. So this number right here that's missing is a 9. Okay. Try it now. Oh, there you go. Try it now. Okay. So everybody take 2 minutes, see if you can get through the whole thing, get it all factored and canceled. All right, I want you to check it with somebody at your table, compare answers, okay? Take a minute and do that, compare answers at your table. You hear a little bit of talking. Okay, let's take a look together. So, what's the very first thing I look for when I factor? Greatest common factor. So in this first one, what's the greatest common factor? 8. All right, what was left behind when you divided? Good. Nothing I can do with the x plus 9, right? And notice, every single problem is a little different. I may have greatest common factor, I might have differences of squares, I might not have to do anything. You got to analyze what's there, okay? All right, what kind of factoring is this one in the denominator? Good, so two numbers that multiplied to 9 and added to 10. 9 and 1. So we have x plus 9 times x plus 1, okay? All right, what kind of factoring is this one here? Logic X. So two numbers that multiply to negative 30 and add the 7. 10 and negative 3. Good. So x plus 10 times x minus 3. All right, what crosses out for sure? Good. Anything else? No. So we've got 8 over x plus 10 times x minus 3. Do not try to FOIL it back together. When we look at the answers, we have them in factored form. So this should just remain the way it is. Don't try to FOIL back. Okay? All right. That was enough, I think, for today. The assignment is Delta Math, but it mixes what we're going to do today with what we're going to do tomorrow. Okay? But I think that's enough for our brains right now. Plus, there's a new GimKit mode out that I think we all need to try. Okay. So I'm going to turn on GimKit. We'll practice some factoring for a few minutes. Okay. So get to GimKit. I'm going to get there too. Give me a minute. Okay. Because I don't have it up and running.